All right, so this is going to be the last screencast for this unit, and it's all about limiting reactant or limiting reagent. And your essential question is, would you want to add more than is needed for a limiting reactant in a chemical reaction? Why or why not? So in order to be able to determine how much you need to add, you have to determine which one is the limiting reactant or not, and if you then would like to add more. So what is the limiting reactant? That's going to be the one that's completely used up in the reaction, meaning there's going to be nothing left. It actually determines the amount of products that you can have. Whereas the reactants that are in excess, they're the ones that are added to ensure that the other reactant is completely used up. The limiting reactant tends to be the most expensive one because that's the one that your reaction is dependent upon. Whereas the excess reactants tend to be cheaper, easier to recycle, or easier to reuse. So when you look at a chemical reaction, the one that's determining how much product you can make is definitely the one that you don't want to waste because it's probably going to be the one that's most expensive. So here's an example, just like a simple, thinking about it example. If I have 4 slices of bread, but I have an entire jar of peanut butter and I have a half a jar of jelly. When I'm trying to figure out how many peanut butter and jelly sandwiches I can make, my limiting reactant here is clearly going to be my bread. I'm going to have excess peanut butter and excess jelly. Now, if I wanted to set up a situation to where I maximized it and I used all of it, I would need to add more bread to make sure that I use all the peanut butter and all the jelly up. But my bread is going to be my limiting reactant. Okay, so the steps to solving limiting reactant problems, you're going to, again, write a balanced equation. For each reactant, you're now going to figure out how much of the product can be formed. And then, so when you go through and you're setting up, if I have this much reactant, how much product can I make? If I have this much reactant, how much product can I make? And the one that's the smaller, or that yields the smaller product, that's your limiting reactant. That's the amount of product that can actually be made. Meaning, with the amount of those reactants that I have, the one that's the smallest, or the one that produces the smallest amount of product is just the one, that's how much product I'm going to have, and then I'm going to have some excess left over. So here's an example. I have H3PO4, so phosphoric acid plus this base, this is a neutralization reaction, plus potassium hydroxide. I'm going to make potassium phosphate and 3 waters, or 3 moles of water. If I have 5 moles of KOH and I have 2 moles of phosphoric acid, how many moles of K3PO4 can be prepared? So I'm going to have to figure out, starting with my 5 moles of KOH. So if I have 5 moles of KOH, how many moles of K3PO4 can I make? And if I have 2 moles of H3PO4, how many moles of K3PO4 can I make? So I'm going to solve both of these problems separately. And I'm going to, so 5 moles of KOH, and my mole ratio is going to be 3 on the bottom, 3 moles of KOH to every 1 mole of K3PO4, so 5 divided by 3. If you go ahead and solve that, you end up with 1.67 moles. If I had, so with the 5 moles of KOH, I can make 1.67 moles of K3PO4. If I have 2 moles of H3PO4, and I want to figure out how much K3PO4, these are in a 1-to-1 ratio, so if I have 2 moles of this, I can make 2 moles of this. But in reality, if I had 5 moles of this and 2 moles of this, I'm only going to make 1.67 moles. I'm going to run out of this, meaning I'm going to use all this up, and now if I have 2 moles, I'm going to have some excess of the H3PO4 left over that I've just wasted. So the most that I can make is 1.67 moles of K3PO4. So I want you to go ahead and try solving this one. This one's a little bit more complicated because it gives you grams. So you're going to have to go through and convert these all to moles and then do your 2 equations. So 24 grams of aluminum, well, I need to convert it to moles of aluminum so then I can use the mole ratio. I'm trying to figure out A2O3. So if I have 24 grams of aluminum, how much Al2O3 can I make? And if I had 190 grams of Fe2O3 of the iron 2 oxide, or the iron 3 oxide, how much can I make? So you're going to have to convert these to moles and then go through and do your mole ratios. And it tells you that you get 0.28 moles of Al2O3, so one of these two is going to give you 0.28 moles. You just have to figure out which one is the limiting reactant. So that's your goal. It's just to sit there and go, okay, which one actually gave me 0.28 moles of Al2O3 made? So one of these is going to be in excess, and one of them is going to be the limiting reactant. And I can tell you, it's not always the one that looks like it would be that has the less amount. So even though you have 24 grams here of aluminum and 190 grams of Fe2O3, or of iron 3 oxide, the aluminum could be your one in excess, and this one could be your limiting reactant. So you actually have to go through and solve the problem. So go ahead and do these practice problems, and then we will work through more in class, and you're going to do a limiting reactant lab.